All right, 3.5 today. We are going to be talking about derivatives of trig functions. So first, I need you to remind me. Who can remind me something they remember about the sine wave? It starts at the origin. Exactly. So it starts at the origin, and it finishes right at 2 pi right here, halfway in the middle. Remember, it went as high as 1 and as low as -1. So it's this wave, this wave that went up here. Right? That sine? Yes. So here's what I want to show you, though. Let's see if we can first find the derivative function of sine. So this graph right here is f of x equals sine x, right? What I want to find is the derivative of this. So the first thing, what we've been talking about, is the fact that at our maxes and mins, the derivative is 0, right? Right? So the slope at our max and the slope at our min is 0. So our graph would be across here. From this side to our maximum, is our slope positive or negative? Positive. It looks like it's the slope of like 1, right? So I'm going to put it out up here at 1 because it's up here. Now, from our maximum to our minimum, our slope is negative. Absolutely. So I'm going to go here and say that it's right around, this one's at this point is probably a -1-ish. And then back here, from our minimum back up, our slope is positive again. So it's up there. Now look at this curve. To represent this, here is the slope curve of sine. It is cosine, exactly. So the derivative, f prime of x of sine x, is cosine x. So all of our trig functions actually work together. All right? So I just wanted to show you that to begin with. Now, knowing you guys like I do, I'm just going to give them to you because what you're going to do is memorize them and not think of them this way, because I know you. Okay, so here's what I want to do. We're going to list them right here. So first thing I want to say is the derivative of sine x equals cosine x. That's the one we just found, right? The derivative of cosine x is negative sine x. The derivative of tangent, the derivative of tangent is secant squared x. Which one do you want to go to next? Let's do the derivative of cosecant x. Move this up a little bit. The derivative of cosecant x is negative cosecant x cotangent x. The derivative of secant x is secant x tangent x. And the last one, what's the only derivative I haven't done yet? Cotangent, perfect. The derivative of cotangent is going to be negative cosecant squared x. We just have to memorize these. I mean, we can recalculate them every single time if we want, but memorizing them is what you guys are going to want to do. Okay? So, just to kind of help you out, anytime we're using like our cosecant cotangent, our cosine. What do you notice about the signs on their derivatives? They're all negative, right? So all the ones that start with C, the derivatives are negative. Okay. What else can we point out? The cosecant and the secant are two pieces, right? Because they're the inverses of our sine and cosine. Yes, very good. Anything else we need to point out? Always squared. Awesome. Good. Okay, so maybe some of those little cues are going to help us memorize these. Okay. Yeah, it'll help. All right, so here we go. That's all we need. So here we go. Find y prime, which just means derivative, which just means dy dx, or f prime of x, or however, they're all the same symbol, right? So I want you to find y prime if I tell you that y equals 3 plus sine x. So y prime, what's the derivative of 3? 0. Okay, so that drops out. What's the derivative of sine x? Cosine. That's it. So it's kind of like, remember when we first started doing the power rule? How it was like short and sweet and to the point? Short and sweet and to the point. Yeah. So we are actually, I can narrow this down for you. Hold on. The first couple examples are all going to cover your 1 through 9. Okay? So let me do another one from 1 through 9. So this is 1 through 9. Again, we're finding f prime of x. I'll say it that way this time. And let's do y, or f prime, or f of x, excuse me. F of x equals 3x squared plus tangent x. Yes, f prime of x is 6x. Maybe let's try again. 6x plus secant squared. Let's try a little bit harder. Example number 3, still from the next section. What if I gave you find y prime if y equals 2x cosine x. It is technically a product rule, right? We have two functions. The first function, or the f of x piece, is 2x. The second one is cosine x. So we're going to do the product rule. So derivative of 2x is just 2. The derivative of cosine x is negative sine x. All right, so the product rule. Y prime equals, start this corner, 2 times cosine x plus 2x times negative sine x, or negative 2x sine x. And that's it. Nothing else to do. No. Nothing to do. Questions, though? No questions? There is one in that 1 through 9 that is also a quotient rule. Do we want one of those? Yeah. Let's throw one up there. Okay. Let's do one like this. Say, for example number 4, I have y equals 1 over 1 plus secant. No, because it's on the bottom, but it's 1 plus secant, so you can't do that. So our top function is just 1. Our bottom function is 1 plus secant x. What's the derivative of 1? 0. What's the derivative of 1? It's 0. Secant x is secant x tangent x. All right, so for the quotient rule, it is 0 times this, right, or 0, minus secant x tangent x times 1, divided by 1 plus secant x squared. So you can leave it just like that if you want. Oh, I mean, you don't have to put the 0, no. I put it there so you guys can still see that's, yes, exactly, the order we're going in. Okay? All right. So let's try the next one. Now I'm really going to throw you for a loop. Example number 5. I'm just kidding. All right. In example number 5, this is going to be your 13 to 15. Are you good? Yep. Pretty easy? Yeah. Good. I'm glad. And yet I'm going to be crying because I'm going to have some that are like below 20%, but that's okay. Thank you very much, Brady. Have a good time. Are you sure it's just because it hasn't been, I'm still recording. Are you sure it's just because it hasn't been made right? You just don't like turkey? Okay. No. Okay. All right, so for number 5, or example 5, we have first, part A is going to ask you to find velocity, speed, and acceleration at t equals pi over 4. Okay? Part B, well, actually, part A and B, we're going to kind of squeeze together. Part A and B. So really, part A wants you to find the different equations. Part B wants you to plug in pi over 4 and find out the values. Okay? So here's our function. Let's say S of t equals, how about 4 plus 3 sine t. All right, so let's just find all of our equations first, right? So S prime of t, which is our velocity, the derivative of 4 is 0, so that's gone. The derivative of 3 sine t, 3 cosine t, exactly. Okay? Then our acceleration, a of t is the derivative of v of t. So that's 3 negative sine t. So finding those 3 equations is part A. Part B, we want to find the values at pi over 4. So we're going to plug pi over 4 into each one of them. So first we're going to plug it into v of t. So let's do v of t equals 3 cosine at pi over 4. And what is cosine at pi over 4? Think of your wonderful unit circles. Yes, root 2 over 2. So this is just 3 root 2 over 2. Nope, you'll be okay. But remember that part of the AP test is no calculator. All right, so let's do, if we were doing speed, that is the absolute value of v of t. So it's also 3 square root 2 over 2. And then I need acceleration. A of t equals negative 3 sine at pi over 4. Whoops. Yep. So it's negative 3 square root 2 over 2. Huh? That's it. All right. Next example. I'm on example 6, right? Example 6. Again, have any of them been really hard? No, right? Okay. So example 6. Find jerk. This is 17 and 19. So I'm going to give you your position equation. S equals, let's go with cosine t minus sine t. All right, to get to jerk, we have to go velocity to acceleration to jerk. So the third derivative. So S prime equals, what's the derivative of cosine again? Negative sine t minus, what's the derivative of sine? Cosine. Okay, then for our second derivative, negative cosine t. Yes, plus sine t. Very good. Anybody got a question why that's plus sine t? No? Okay. So the derivative of cosine is negative sine. So the two negatives together become a positive, yes. And then our third derivative for jerk is going to become a positive sine t plus, what derivative of sine t is? Cosine t. Huh? Yes, that was one example. Okay? It's just doing the third derivative. Yeah. Yes, that's jerk. That's fine. Yep, that works for me. All right, so we have no questions there. So we only have like, 21 through 31 to go? Let's see. So let's talk about 21 and 23 first. Okay? Example number 7. So this is 21 to 23, and we'll come back to the ones. Okay. So let's go with find the tangent and normal lines of y equals secant x at x equals pi over 4. All right, so again, let's talk about what that actually means we have to do. When we are finding tangent and normal lines, we have to find the slope, right? Okay? And then, of course, we're going to put it into point-slope form, which means we have to have a point. So the first thing we should do is find our point. I think that's the first thing. So to find our point, there we go. We know our x is already pi over 4. Our y value, though, we have to plug pi over 4 into here. So the secant at pi over 4, think about it, it's 1 over cosine, which is square root 2 over 2. So what is going to be the secant at pi over 4? So we'll multiply by the reciprocal, so 2 over root 2, right? And then I have to rationalize root 2 over root 2. So we actually get 2 on the bottom and those cancel. So it's just root 2, right? Does everybody agree? Yeah, does everybody got that? Or should I do it again but do it a little bit bigger so we see it? Yeah, absolutely. Let's try it one more time. All right, so first of all, secant is the inverse of cosine, right? 1 over cosine. And the cosine at pi over 4 is square root 2 over 2. We all agree with that, right? Now to simplify this means that we multiply by the reciprocal. So we're going to take this from the bottom and times it by 1, but it's 2 over root 2. So right now I have 2 over root 2. But we can't have a radical on the bottom. So what do we have to do? Rationalize. So square root 2 over square root 2. On the top, we get 2 square root 2. On the bottom, we just get 2. And so what happens to our 2's? They cancel. So our y value is square root 2. Okay? All right. So now we have a point. So now what we have to do is we've got to find the derivative so we can find the slope, right? All right, so y prime equals, good, secant x tangent x. All right, and we plug pi over 4 into that. So secant of pi over 4, tangent at pi over 4. Okay, so secant of pi over 4 we just did, right? That was root 2. The tangent at pi over 4 is root 2 over 2 over root 2 over 2, so it's just 1. Yep. So this is root 2 times 1, which means our slope is root 2. All right, so now we have a slope and we have a point. So we have for our tangent first, tangent line, we have y minus root 2 equals root 2 times x minus pi over 4. We're still good? So in AP Calc, all you have to do is add that root 2 to the other side. You don't have to distribute. You don't have to. You can if you want to, but you don't have to because you cannot simplify it anyway. So if you decided to distribute root 2 times x minus pi root 2 over 4, and then you can just add root 2 to the other side. So whether you leave it like this and put plus root 2, or you distribute and put plus root 2, the same exact thing, so it doesn't matter. Okay? Which way would you guys like to do it? Just leave it like this? Leave it and plus root 2. Okay, so let's do that for our normal line. And normal means that it's the reciprocal. Very good. So we have y minus root 2 equals negative 1 over root 2 times x minus pi over 4. And guess what? In calculus, we can leave it that way, except we just got to add a root 2 to the other side. So y equals 1 over root 2 times by x minus pi over 4 plus root 2. So it's the same thing we've been doing for like months, right? It's just that we have a couple harder numbers in there, but it's still the same stuff. So, okay? 2 examples left, and I'm done. No. All right, I'm on example 7, right? Yes. Example 8? Example 8, yes. You're going to need a little more room. Example 8 is going to help us with 25. Yeah, let's just do 25. 25. So refer to this one when you're looking at 25. No, we can't just do 25. Prove. Love ya. All right, prove that the derivative of cotangent is equal to negative cosecant squared x. All right, so here's what we're going to do. I got to write that a little bit better in case somebody else is watching. There we go. All right, so to prove this, first of all, how else can I write cotangent? We could write it as 1 over tangent. Is there any other way? You're close. That's the derivative. That's what we're proving. That is true. I agree. Yeah, so it would be cosine over sine. There we go. Let's use that one. So if I did, instead of saying cotangent x, I want the derivative of cosine x over sine x. So, similar, just not finding the derivative, but we're on, yeah. Exactly, yep. So, in this one, if we're going to find the derivative of cosine over sine, what rule are we using? No, that's not what I mean. If I want to find the derivative of things in fraction form, the quotient rule, exactly. So we're going to do the quotient rule. So we have cosine's the one on top, sine's the one on the bottom, right? Derivative of cosine is negative sine. The derivative of sine is cosine. All right, so now we're going to do the quotient rule. Negative sine x times sine is negative sine squared x minus cosine times cosine is cosine squared x all over sine squared x. Okay? Now, what can I undistribute out of the top line? I can take out a? How about let's take out a negative 1. Just take out the negative, right? Okay? So if I take a negative 1 out, on the top I have sine squared x plus cosine squared x, which equals 1, exactly, over sine squared x. So right now we have negative 1 times 1, or negative 1, over sine squared x. Well, what is 1 over sine squared? It is negative cosecant squared x. And so you just proved it. It was not as bad as you thought.
I'm trying to remember the sine squared x.
Exactly. No, but yeah, we can get a new card out if we need to put another one together. Okay, I will consider that for tomorrow as part of our. Oh, look at her go. Yeah. Well, that's why usually at the end of the year I like try and collect your cards and hold on to them for you. But see, you guys didn't stay for exams. Like usually I like collect them after exams, but this year he let everybody out of exams, so I couldn't get all your cards to hold on to them. You guys are seniors. There's a difference. All right. So are we good? One more example? Example number 8? No, number 9? Example 9. I know. But the first couple were like really quick and short. And all right. So this is going to cover the rest of it. 27, 29, 31. Okay? All right. Show that the what? I'm recording, you guys. All right. Show that the graphs of y equals secant x and y equals cosine x Let's keep going. All right, so on this last example, I want you to show that the graphs of y equals secant x and y equals cosine x have horizontal tangents at x equals 0. All right, so really what does that mean? Horizontal tangent is a horizontal line, right? It's a constant. That means that our slope at 0 has to be 0. Exactly. All right, so here's what we're going to do. We're going to find the derivative of secant. All right, so we have secant x, and so the derivative is secant x tangent x. I don't need your mom more mad at me. All right, so now if we want to know what it is at 0, we're going to plug 0 in, right? So we're going to plug 0 in for x. I need secant at 0 times my tangent at 0. And I need to show that this equals 0. So let's see if it does. Secant at 0 on our unit circle. That's over here. It's at 1, 0. Secant is 1 over 1, or 1, right? 1 over cosine. So secant at 0 is 1. The tangent at 0 is sine over cosine, or 0 over 1, which is 0. So what is 1 times 0? Look at that. The slope is 0 at 0. Right. Yeah, so we're going to do the same thing with cosine x. So if y equals cosine x, the derivative of cosine x, negative sine x. And so now we want to plug 0 in for x. So y prime equals negative sine times of 0, Well, it's still the spot right here. So what is sine? It's 0. So we get negative 0 or 0. Yep, it's always cosine sine. Remember, sine is your y value. Okay? Not so bad, right? Yeah, we're all done. Oh.